When you pluck a guitar string, the pitch that you hear is called the fundamental, or the main pitch of the string. And up here at this first one here, we see what that would look like. The sound actually goes back and forth on the string really rapidly and creates some pitch. But there's also a lot of other pitches that are created that we don't hear directly. They help together form the main type of sound or timbre of the guitar string. So it not only vibrates like this at its whole length, but also vibrates in halves and thirds and fourths and fifths and sixths. Notice how the number goes up 2, 3, 4, 5, 6, 7. It keeps on going up like that. And each of these harmonics has less energy, less loudness than this fundamental. They don't sound as loud, so they get covered up to a certain degree by their main sound, but they do contribute to the overall, again, timbre or color of the sound. If we were to actually look at what pitches that these create when these extra overtones or these extra harmonies or harmonics are created, if we were to look at what notes they've represented, if that first thing here that we plucked was a C, then the next one up would be the next highest C, then a G, then a C again, then an E, G, B flat. It would ultimately create a major chord, or in this case, if you're looking at all these here, it creates what's called a major minor 7 chord or dominant 7 chord. So sometimes they call this the chord of nature. Let's now hear what happens when we put these things together. So I'm going to go over to this program called Max MSP. So here they have something called osbank or oscillator bank. It just means stuff that vibrates and makes sounds. And if you look over here where it says draw amplitude curve, this is showing a fundamental pitch, and all the rest of these represent harmonies that are multiples of that fundamental pitch or harmonics. I'm going to take the value of them and put them all down to nothing except for the very first one, and then hear what it sounds like. Pretty bland. That's because this is an artificial type of sound. This is like a sine wave, and it doesn't actually produce its own harmonies or overtones. So we're going to simulate it by adding multiples above it. Here it is again. But now I'm going to add the next harmonic to it. Twice as high. Fifth above. 4 times as high. Major third above that. Minor third. The 7th. The next one's up there. Now as I played that, you could hear the individual ones that were there. But now listen to this. Now our minds kind of just decide that that whole thing is just one unit or one type of sound. If you take a sound that has an open end on it, a string doesn't. It's stopped on both sides of the guitar. But if you have like a clarinet or something which is open at the end, it causes it to only make odd harmonics. So it's missing this second one. It's missing that one, missing this one. Only these light blue ones would be up. What would that sound like? It won't be this, but it'll be similar. Maybe it's too much of these. Again, rough, but sort of an approximate sound of clarinet. So by adding different partials in here, adding different harmonics, and changing how loud they each are, it has a big impact on the overall sound color or timbre of each sound.